Today we're going to look at section 2.1 and 2.2. What we're going to do is we are going to recognize complementary and supplementary angles. So let's go ahead and take a look at this example. So we've got given to us angle TRX is a right angle. So I'm going to go ahead and mark that in my picture. So if I follow the letters TRX, that's this angle right here. I'm also told that the measure of angle TRS, this entire angle, is represented as 2x plus 5y. We're also told that angle XRS is represented as 3x plus 3y. So we are asked to find both x and y. Thinking back to our very first chapter, we can only assume one type of angle. We can only assume straight angles. And notice that that is what angle TRS is. It's forming a straight angle. We know what that angle TRS is representing. So that's an equation that I'm going to be able to set up. I'm going to be able to set up that 2x plus 5y equals 180, because once again, that's how many degrees we have in a straight angle. Now, unfortunately, we can't then solve for x or y because we have two variables in the same equation. So this means that we have to set up a system of equations. So we need one more equation with the x's and the y's. The only other expression we have is this 3x plus 3y. We can't assume any type of angle. However, with us being told that angle TRX is a 90-degree angle, if I know that I have a straight angle and one of the angles that helps form it is 90 degrees, hopefully it makes sense that on the other side that also has to be 90, because 90 plus 90 will make that straight angle of 180. So because now I know that angle XRS is represented as 3x plus y, but it's also a right angle, I can take 3x plus 3y and set it equal to 90. And now I have a system of equations I can start solving. So we have it set up in elimination mode. Because I don't see opposites, we could try to then create them. So it doesn't really matter which one of these variables we eliminate first. I'm going to eliminate the y's first. So because there's a positive 5 and a positive 3 in front, I want to think about the first number that those have in common. Well, 5 and 3, 15. So I'm going to make the top equation have that y turn into positive 15. So that means I have to multiply by 3. So that means the bottom equation, I want y to be a negative 15. Well, if it's positive 3, I need to multiply by negative 5. So I'm going to distribute the 3 to the entire top equation. 3 times 2x is 6x. 3 times 5y is 15y. And 180 times 3 is going to give us 540. On the bottom, I'm going to distribute the negative 5 to all of those terms. Negative 5 times 3x is negative 15x. Negative 5 times 3y is a negative 15y. And 90 times negative 5 is negative 450. So now that I have opposites with the y's, I can add up my columns. I'm going to end up then having negative 15 plus 6, which would give us a negative 9 with that x. The y's cancel, and 540 minus 450 is going to give us 90. I'll divide by negative 9. And so one of our answers, we just got x to be negative 10. We're not finished. Now we have to solve for y. So now that I know what x is, I can go back to either one of my original equations and solve. I think I'll go back to the original bottom equation. So we'll have 3 times negative 10 plus 3y, that equals 90. 3 times negative 10 is negative 30. We still have plus 3y equals 90. Got to get the y by itself. So I'm going to add the 30 over to the other side. That gives me now 3y equals 120. I'll divide both sides by 3, and that gets me my final answer. 120 divided by 3 is a positive 40. And there are my two answers. Okay, so it took us going back to the idea of the first chapter where if we have a right angle that's 90, we can only assume straight angles. All right, if we take a look at another one, we're told that the ray AC bisects angle BAD. So that means that these two smaller angles down here, angle BAC and DAC, are going to have to be congruent. The second given information is that the ray CA bisects angle BCD. So that's this angle up here. That means that I have two other angles that are congruent. Notice that I had to mark those separate from the angle A's down at the bottom because I don't know that all four are congruent. We are told that the angle BAC, so that's this expression down here, that's 3x, oops, let me write this better. Well, 3x plus 15. We're told that angle BCA, that's this up here, is going to be, BCA is 5y plus 6x. We're told that angle DAC, so back down here at the bottom, is 7y plus 1. And we're told that the angle DCA, back here at the top, is 9x plus 4. We want to find the measure of the angle BCD. So that means BCD, we want to find this entire angle. In order to do that, we're going to have to know what x and y are. So because I have some congruent pieces and congruent meets equals, that's how I'm going to start. So up at the top, 5y plus 6x, that's going to have to equal 9x plus 4. Because there are two variables, there's x and y, this is another system problem. I can set up a second equation with x's and y's, and then we can decide between substitution or elimination to then solve. So with the angles down at the bottom being congruent, we can say that we have 3x plus 15, and that equals 7y plus 1. All right, so I think that it would be a good idea to rearrange these and get it into the elimination mode. So I want the x's and the y's together on one side, and I want it to equal the number. So if I look at the top equation, that means that I'm going to have to move that 9x over to the other side because I want to keep that number 4 where it is. On the bottom, I'm going to move that 15 over to the right-hand side, but then that y has to get moved over to the left. All right, so my new then system, when I start doing all that, I'm going to put the x's first. So on the top, 6x minus 9x is going to give us a negative 3x. We'll still have that positive 5y, and that equals 4. In the bottom, I'm going to keep the x first. We'll have 3x. Now we'll have a negative 7y, and that's going to equal 1 minus 15, so that's negative 14. The nice thing about doing that rearranging is notice that, hey, my x's are already opposite. I can start then eliminating right off the bat. So the x's disappear. 5y plus a negative 7y is going to give us, I'll write that up here, negative 2y. And that's going to equal 4 plus negative 14, which would give us negative 10. I'll divide both sides by negative 2, and we get a value of y to be 5. Once again, if I want to find the measure of the angle BCD, I need not only that y, but I also need the x. So I can go back to any equation I want. I'm probably going to go back to the simplified ones right here. I'm going to plug the 5 in for the y in that bottom equation. So we'll have 3x minus 7 times 5, and that equals negative 14. So we're going to have 7 times 5, which is 35. We'll add that 35 over to the other side. So that gives us then 3x equals, let's see, negative 14 plus 35 is 21. And then I'm going to divide by 3. And so that gives us a value of x to be 7. All right, so to find the measure of the angle BCD, I'm going to have to take those two little angles and add them together. So we're going to have 5 times 5, because that's my y, plus 6 times 7, because that's my x, plus 9 times 7, because that's my x, plus 4. Well, 5 times 5 is 25. 6 times 7 is 42. 9 times 7 is 63. So now I just want to add up all of those numbers. So we got 25 plus 42 plus 63 plus 4. So that tells us that this angle is 134 degrees. Okay, so the idea of bisecting creates two congruent pieces, and so then congruent means equals. All right, here's a word problem for us. It says the measure of one of two complementary angles is 3 greater than twice the measure of the other. We want to find the measure of each. So anytime we're doing these complementary, supplementary word problems, I'm always going to let x equal the angle. Okay, so then in this case, we're talking complementary. So that means that my complementary angle, remember, complementary means that two angles add up to 90. So if I'm letting x be one of the angles, my complementary angle is going to have to be 90 minus x. So just an example, say one of my angles was 40. Well, then the complement would have to be 90 minus 40, or 50, because 40 plus 50 gets us back to 90. So that's what I mean. So one of my angles is x, then the complement is 90 minus x, because together they'll add up to 90. So if I have those two expressions, it once again says the measure of one of two complementary angles. So it doesn't matter. We can just choose x as the angle, or we could choose the complementary angle. It doesn't matter. I'm just going to choose x. So I'm going to say x. Anytime we see the word is, when we're thinking about a word problem, is going to mean equals. So one of two complementary angles is, so x equals. Then it says 3 greater than twice the measure of the other. So now that I chose x as my one angle, then I have to choose the complementary as the other. So it's saying 3 greater than twice the measure of the other. So twice the measure means that 2 has to get multiplied by that. I have to double that angle. But then if it's 3 greater, I'm adding 3 onto it. So this is my equation. It says find the measure of each. So we'll start by finding x. So x is going to equal, over here I'm going to distribute. We've got 2 times 90, which is 180. And then 2 times negative x is negative 2x. And then we still have to add 3. I'm going to add the 2x over to the other side. So now I have 3x equals, and then I've got 180 plus 3. So I've got 183. And so then 183 now has to get divided by 3. And so we get x to be 61. So since x is representing the angle, that's one of the angles. So I know that I've got a 61-degree angle. And now I have to find the other. So the complement, remember, then would be 90 minus 61. So that means that 90 minus 61 is going to give us 29. So I know that the measures of each, I've got a 61-degree angle and a 29-degree angle. And there are my answers. Let's take a look at another one. It says the measure of the supplement of an angle is 60 less than 3 times the measurement of the complement of the angle. We're going to find the measure of the complement. So once again, I always let x equal the angle. So in this first one, it's talking about the supplement of the angle. Remember, supplementary means that we have two angles that add up to 180 degrees. So if x is my angle, 180 minus x is going to have to be the supplement. So once again, if I just throw in a number, if I say that my angle is 30 degrees, Well, then the supplement is 180 minus 30, so it would be 150 because 30 plus 150 gets us 180. All right, so rereading that first sentence, the measure of the supplement of an angle is. So if I know that my supplement is 180 minus x, we've got that word is, so that means equals. Now it says 60 less than 3 times the measurement of the complement of the angle. So remember from our last problem, complementary means two angles add up to 90. If x is my angle, the complement is 90 minus x. So 60 less than 3 times the measure of the complement. So I have to multiply 3 times the complement. And then if it's 60 less, I want to subtract 60 from it. All right. They want us to find the measure of the complement. So in order to find the complement, I need to find x first. So that's what I'm going to do. So I'll keep the 180 minus x on the left. I will start distributing on the right. 3 times 90 is 270. 3 times negative x is negative 3x. We still have minus 60. So we'll have 180 minus x equals, if I combine like terms, we'll now have 210 minus 3x. I'm going to get the x's to the same side, so I'm going to add 3x over to the left. That will give us now 180 plus 2x equaling 210. I'm going to subtract 180. So now 2x equals 30. And I'll divide by 2 to get x to be 15. But once again, that's not my answer. I didn't ask to find the measure of the angle. I asked to find the measure of the complement. So the complement is going to be 90 minus 15. Well, 90 minus 15 is going to give us a 75-degree angle. All right, here's another one. The larger of two supplementary angles exceeds 7 times the smaller by 4 degrees. We're going to find the measure of the larger angle. So we're talking about supplementary angles. So once again, we're going to let x equal the angle. And so to be the supplement means that it has to be 180 minus x. All right. So the larger of two supplementary angles. We don't know which one is larger. We don't know if the angle x is or if the supplement is. So once again, it's just a matter of you choosing which one it is that you want to start with. So I'm just going to start with x. So x is going to equal, okay, because now it's saying that it exceeds it 7 times, exceeds 7 times the smaller by 4 degrees. So that means that I'm going to take 7 times the other angle, which in this case would have to be the 180 minus x. And it says if it exceeds it, that means that we are going to have 4 more degrees. So now I'm going to start solving for x. So I'm going to distribute that 7. So let's see. 7 times 180 is going to give us 1,260. If I distribute the 7 times the negative x, that gives us negative 7x. We're still going to add the 4. So I'm going to add the 7x over to the other side. That gives us 8x. When I combine like terms on the right, that gives me 1,264. I'll divide by 8. So 1,264 divided by 8 is going to give us 158. All right, so it's asking to find the measure of the larger angle. So if x is representing 158, obviously then the supplement of that angle would be 180 minus 158. So that's only going to give us 22 degrees. So if we're choosing between the two larger numbers, or 158 versus 22, the larger angle is going to be the 158-degree angle. Okay, so that's us doing things with complementary, supplementary angles, as well as we really did some system problems as well.